Hi guys, I'm Azhar. Welcome back to another Grasshopper tutorial. Today we are looking at Archibong's Pavilion of the African Diaspora. It's a pretty awesome pavilion. We're going to look at like catenary curves, divide, range. It's going to be pretty awesome. So if you want to follow along, make sure you use that download link below to download the exercise files. And if it's your first time here and you want to learn computational design tools, go ahead and click the subscribe button. Also, if you want the most effective way to get started with Grasshopper, check out my free intro course at onehourgrasshopper.com. I'll teach you step by step the right way to learn Grasshopper and how you can avoid common mistakes that most users make. Again, that's onehourgrasshopper.com. Let's get started. So you can see in this photo, the pavilion here, there are these, like these curved bench-like structures, and these footings essentially have then these tubes or pipes that are coming out, and then there is some kind of fabric in between them. So you can imagine these are like catenary curves spanning an equally spaced like curve over here in Grasshopper, and then we're going to create a surface in between them. Let's find another image. There's Ine. Let's see over here. Yeah, exactly the same thing. So this is how we're going to get started over here, is first figuring out what that curve is and then finding a way to connect in between the two. So let's head over to Rhino, and you'll see in the file that I've given you is you have some base circle over here, and then there's these, the same kind of platforms that you see in the photo. So I'm going to go ahead and hide those. That's under brep seating, sorry. So those are hidden now, and let me open up Grasshopper. So here in Grasshopper, you'll see that I've given you that base circle, right? It's already referenced in here. Let's go ahead and first start dividing that curve. So you'll notice if I type divide curve and put something in, let's put a number in like, 15 or something. So here's a simple divide curve command. And of course, the curve that I'm dividing right now is the circle, but I don't want to divide the circle. I actually want to divide the circle only within this area here. So the way you do that, the way you extract only a portion of a curve is called a subcurve. So before I do this, before I divide, I need to add like a subcurve over here. Subcurve, as you type sub, you'll see subcurve right here. Go ahead, click that. And this one, again, is going to ask for a base circle. So it's going to ask for some kind of curve, which is our circle. But then it asks for a domain. Okay, so if you haven't worked with domains before, essentially you need two numbers, like a start number and an end number. In this case, since we're dealing with a curve, you need a number between a 0 and a 1. That's the easiest way to do this. So we need to construct a domain. Okay, construct a domain. And that domain then gets connected here. And to construct a domain, I need a start number and an end number. I'm going to create some space over here by moving this away and moving this in, and probably move this here as well, since we primarily need to see this part of the screen. So I'm going to start at, 0.25. Again, I can always change this, right? At 0.50, something like that. Just creating two sliders and seeing what that subcurve looks like. Now, if you have my components, you'll notice that you can try and use red line, and it'll show you exactly what part of the curve is extracted, and you can see like right now that's a really small portion. If you don't want, if this doesn't work for you, you can also just hide everything else. So hide that, hide this. Even in Rhino, you can hide this, and you'll see that that little portion of the curve has been extracted. That's not what we need. We need something much larger. And the reason that's happening is because your curve is not reparameterized. So you need this input for the subcurve component. You want to right click on the input and reparameterize. This tells Grasshopper, treat the beginning of the curve as 0, treat the end of the curve as 1. And now you'll see that is a much larger portion. So if I take the 0.25 and I scroll back to 0, that's kind of where the curve starts. And you'll see I had a 0.5, so it went halfway through the curve, so that's a full semicircle. If I continue going up, it'll complete the circle, and if I continue going down, it's gonna come towards the start point. So we kind of want something here, okay? Something like that. It doesn't have to be perfect, okay? Something like that over there, and then that curve, that subcurve, is what you're going to use and place in your divide curve, okay? And now you see that curve, only that portion gets divided, and of course I can reduce or increase that number as needed. So let's go ahead and repeat that for the other side. So to repeat that for the other side, all we have to do is just grab everything we've done over here, copy, Control C, paste, Control V, bring that down. And now, again, the same thing. We just want to adjust these numbers to get the other part of the curve. But we have a problem here. You notice I can't really go below 0. Like I want to start maybe here and here, right? I can't really do that, right? It's going to be very difficult using this method. So the way you want to do that, the reason this is happening is because the 0 point, the start of the curve, the circle, the start of the circle is actually here and it's falling right in between this. And I did that on purpose to show you another command you can use. You can always move the 0 point, so to speak, of any closed curve using the command seam, S-E-A-M. Okay, so by seam, what you do is you can actually adjust where that 0 starting point is. So in order to see that 0 starting point, if I hide everything, for example, and I use the command endpoints, if I use endpoints and plug the circle into endpoints, you'll see where the start and end is. And you only see one point because the circle starts and ends at the same point. Now, watch what happens if I change the seam. So plug this under here and plug this under here. And again, remember, the seam asks for a parameter, right? Anytime you see the word parameter in Grasshopper and there's another input, which is a curve, just go ahead and always reparameterize it. That's just a good habit you can get into. And now if I, for example, use a slider 0.25, you'll see that I'm changing the seam. You see, notice now the new curve, its start and end point is now here. So for example, if I slide this over to like halfway through, it goes to the opposite side. If I come here, it goes all the way here. So I'm going to leave it right over there, like, 25% of the way down. So instead of using a slider for that, I actually am going to prefer to use a panel, and that's easy. Just double click and use the double quotations, 0.25, hit enter. That is your seam. So if you have been following along so far, I just want to say thank you and let you know that there's so much more out there to learn. This is just the tip of the iceberg. Learning over YouTube is completely different from actually using these skills in a real project. Let me show you how I help architects take their skills to the pro level, where they are making a difference in their projects, portfolios, and careers, all in just a few weeks. If you want to learn how I can help you get to the next level, click the Computational Design Studio link in the description box below and schedule a call with me today. So now this curve starts over here, so it should not affect these two too much. We may have to readjust some numbers, but that's okay. So again, we adjust the seam and then we plug into the subcurve. So I'm going to slide everything over just a little bit, just like that, so it stays organized. And now we do the exact same thing by adjusting the values. So let's start with the first one and let's adjust its values so that it kind of starts approximately here, and adjust the second one and adjust its values so it starts approximately there. Again, doesn't have to be perfect. Okay, we're just kind of getting the gist of it, getting an eyeball off it. All right, now we have those points. Notice I have two sliders, one for one curve, one for the other. That really doesn't make sense. You should have the same number of points on each curve. So I'm just going to use one slider to do the job of both of them, deleting this one. Don't need that anymore. And now I have points for one side and points for the other. How do we create that arc in between them, right? Of course, this curve right here, how do we create that? Well, the way we can do that, let's go back to Rhino, is by using a catenary curve. Catenary. And if you type in catenary, and I spelled it wrong too, yet it found it, catenary, that's what we need. So the way catenary works is you give it a point. So we have one set of points. Good. You give it another point where it ends. It ends right here, so we'll give it that. Then it needs two other things, length and gravity. Okay, so length is how long is the curve. That kind of makes sense. And gravity is like which direction is the catenary pulling in. So you can see, like, for example, this arrow, if you're pulling down in the Z, it's going to go down. Let's worry about gravity later. Let's look at length first. So what length do we put in? Well, I have no clue what length we put in. First, let me kind of just check the distance in between these two over here. So I'm just going to use a line command, okay, and just click somewhere here and kind of head over the other way. And you see it's about almost like 20 feet. Okay, so I'm just going to enter a number like 25 and just kind of see what that gives me under length. Okay, and notice I plug that in. It creates a catenary curve and they're all kind of going down. So first let's fix the down to go up. All right, and the reason that's happening is because gravity is pulling down, right? Negative z, it's going down into the earth. We want to actually reverse gravity and kind of go up. So instead of going -1 in the z, to go +1 in the z, all you do is give it just a regular z vector like this, and now it'll go up. Okay, so we fixed that, but look at this. This doesn't look right, you know? One's going one way, one's going the other way. Why is that happening? Some of you may already know what's happening, but one way to check is always using a point list. This is super useful. So if I hide the points, for example, and use point list, and I'll create 2 of them. So one point list for one curve, one point list for the other curve. You'll see that in this point list, you have the points starting here, 0, 1, 2, 3. And on the other curve, they actually start on the other side, 0, 1, 2, 3. So the 0 is connecting with 0, the 15 with 15, 23 with 23, and that's why we're getting that kind of language here of them crossing each other like that. So that's an easy fix. All we have to do is right-click on this output here, on either one, doesn't matter which one, and you can just reverse it. And so what that does is just reverses the list, and now you can see this 0 should match up with this 0, this 15 with this 15, and that 23 with this 23. Let's see if that works. Yep, that works a lot better. Let's go back into another view, and you'll see that if I gave it a constant number, like 25 as the length, this is kind of what it looks like. And it's giving this swoop just because those 2 points are actually further away. So that same length has to travel a longer distance, and therefore it gets a little bit shorter here, versus the ones between the ends that are a little bit closer to each other. But that's not the language we want, right? We want the one in the back to be the shortest, and then the one in the front to be the longest, okay? If you want something like that, then we kind of have to work a little bit differently, okay? So anytime you want numbers that are incrementally going up or down, you can either use a range or a series. Okay, so you can use a range or you can use a series. Now, I'm not going to mainly go between the differences of these. I'm just going to end up using a range because I just have a gut feeling that this is going to work a lot better for me. So the way you use a range is here. Let's pull up some numbers here. So a range creates now a range of numbers between 0 and 1 and needs a domain. And we just dealt with the domain earlier, didn't we? Right here. When we did SubCurve, we had a domain and we had these two. So I'm going to copy this part over, which is the construct domain and the 2 sliders. Okay, and notice what happens if I plug them in. So basically this controls that very first number, this controls the end number, and the steps is how many numbers in between. Now notice steps, if you enter 10, you actually get 11 numbers. So that means that the number you put in here should be 1 less than the numbers you have over here. All right, now what number do I need as my start, as my end, as the step? I really don't know yet, but we're going to figure that out. Okay, so let me come back over here to the catenary. The only thing that's really missing here, everything else is working except for a length. That's the one we need to change, right? So I'm going to delete that slider so the component doesn't work. And let's think about what length value we add in there. So since in this particular project, you notice how it starts small, large, large, large. I can't just give it numbers, like absolute numbers. Okay, if I gave it absolute numbers, what's going to happen is it's going to also depend on how far those points are. So even if, for example, this one's length was larger than this one, they may appear the same height just because this point may be further apart than these two might be closer, right? So we don't want that. We want them actually to be relative to the distances that are currently in between them. And what I mean by that is something like this. I can calculate the distance in between any 2 points. So if I calculate, for example, the distance between the start point and the end point, right, from one end to the other, if I calculate that distance, I get something like this. And of course, no 2 distances are the same. They're all kind of different, right? They go up to 19 feet and they're down as low as 15 or so feet. So how can I deal with this? Well, one thing you can do is, what if you always went a little bit higher than the distance? So if I drew a catenary curve that's the exact distance between them, I'll just get a straight line because that's the shortest distance between those 2 points, right? Just a straight line that's perfectly flat. But what if I multiplied? So if you start typing in, you'll see multiplication. What if I multiplied each of those distances and like double them. So I multiplied it by 2, for example, right? And I put that into length. And you'll see that you get something like this. Wow. All right. So that's big, right? But what if I don't multiply it by 2? What if instead of multiplying all of them by 2, I multiply the first one by a smaller number, the second one by a little bit larger, and then a little bit larger, a little bit larger, a little bit larger, and so on, right? We can do that by using a range, right? So here's my range again. And again, what I'm trying to do is multiply the distance in between the points by what? By a number that starts somewhat low and then goes much higher. So of course, you have to have that number at least larger than 1, right? It's got to be bigger than 1. So we're going to create a slider that at least starts at 1. So the way I'm going to do that is type in 1.00. If you know the bounds of the slider, then just go ahead and create it like this. So for example, I'm going to create a slider that goes from 1 to 2. So 1.00, and then just type ... 2.00. And what that's going to do is create a slider that goes from 1 to 2 with 2 decimal points. Okay? And I'm going to plug that in to the start of my domain. Now, I'm also going to use the same slider and plug it in the end of my domain. And I'm going to give this some number and this some other larger number like that. Okay? Now, what's it going to do is it's going to create a range of numbers that starts at that first slider, ends at the second slider, and even increments in between. Now, how many of these do I need? Well, I need 1 for each of these lines. So first I need to know how many lines there are. So if I come over here to points, I mean, this number of points is the same as the number of lines. So I can actually use list length. Okay, list length, and I can get how many points there are here. And you see there's 24 points. So I can plug that 24 in here, and I should get, oh, no, remember, if you plug in a number, you'll actually get 1 higher. So I end up actually with 25 points. So what I need to do is reduce this by 1 and plug it in here. So you can do it a couple of ways. One way is to just right click on the output and put an expression in like x minus 1. What that does is it says, hey, before you leave this output, make sure you do this special operation, which is take that number and just subtract 1 from it. So instead of it being 24, now the number 23 comes out. 23 comes in here, giving us 24 numbers, which is great because that's exactly how many lines we have. And then I can plug this range into the multiplication here. And notice what it does. So what it does is it multiplies the very first number by 1.13. So it increases it by like 13%. Okay? As we work towards the last one, which is being increased by 60%. Okay? So we can mess with these numbers now. So if I zoom out and kind of mess with these, so I can, of course, increase that or decrease that, increase much further the first one, right? And get something like this. So that's already looking a lot better. All right, and that's how you do that part. Now let's go ahead and actually connect these curves together to create that lofted fabric form. Okay, so these catenary curves right here, these I can save as a curve and call this, you can call it really anything that helps you keep organized. I'm going to call it the structural pipes. Okay, and then what do I do with this? Well, I need to actually loft them with each other, right? So I could use a loft command like this and just loft everything and create one big surface, right? But that's not what I want. I want to kind of follow what's happening here and I'll create each individual surface separately. So the way you want to do that is I have a component that's super useful. It's called make pairs. Of course, with any of my components, you can just go ahead and download them. So what make pairs does is it takes a list that looks like this. Okay. This consists of, so many polylines, for example. And if you put that in here in make pairs, what it does is it actually turns those into pairs, exactly what the name suggests, right? It makes them into pairs, which is really great because that, if you put in the loft command, will actually make individual strips. Now it's kind of hard to see, so let me bake that just for a second so you can see what I'm talking about. And this is what it bakes. You see, it bakes individual strips. However, this strip is looking actually quite terrible because it's, composed of so many multiple segments. Why is that happening? Well, the reason this loft is looking like this is because of these curves, right? Actually, let me go ahead and delete this bake. Okay, the reason that's happening is because the catenary curve is actually more complicated than it needs to be. Here, let me demonstrate what I'm saying by using control points. If you type in control points, you'll see that this catenary curve has a lot of control points. Look at that. That's too many. Okay. And so that's why when you're doing a loft, it's actually creating each individual little kind of mini segment in between, which is not making it look very good. You just want one nice smooth surface that's going across. So what I like to do is before this goes into a loft command, what you can do is rebuild it. Okay. So if you type rebuild, you can rebuild the curve. Okay, and you can basically simplify that curve. So even just plugging this in and looking at what's highlighted in green here, you can see that it's actually a polyline, right? That doesn't look right. It looks like a polyline. So why is that? If you go under degree, you actually want to enter the degree of a curve. Now, without getting into too much math here, a degree of 3 should be just fine to give you a nice curve. Curved curve, so to speak, not a polyline curve. Okay, if that makes any sense. And then you can also enter how many control points you want. So for example, now there's 10 control points. If I keep both of them open, the original catenary and the rebuild, you'll see that there is, of course, some difference between them, right? They're not perfectly matching. There's some slight difference between them. You can reduce that difference if you give it more points. So for example, if I gave it 30 points instead of 10 points, you see that it's a lot closer to the original. And here I'll slowly go down. And so you'll see that difference there. You see it starts to not be as accurate. And then, of course, if I go up, it'll be more accurate. So really depends how many points you need. But if you rebuild a curve, it should probably loft a lot better. Let's demonstrate and see if that works. So I've rebuilt the curve. That goes into make pairs. That goes into the loft. And that gives you a much better result. Look how much smoother that is. Right, compared to before. That looks a lot better, and I think we're pretty much done here. So all I have to do is just preview this. So hide the original, plug it into preview. I'm going to change the edge color here. So change the edge color to black, both naked and edge. And there we go. That looks a lot better. It seems like I have some line on here. There we go. Turn that off, and that should do it, right? That is the end of that. Now look at this. I can, of course, adjust a few things. So we can come back here and adjust where that curve lies on the base, right? We're using these domains. You can use these domains to control how low and how high it goes. And yeah, that's pretty much it. So that's our tutorial, guys. And the only other thing is, of course, the number of bands. You can have fewer bands or more bands. All right. So if you enjoyed this tutorial, give this a thumbs up. And of course, if you have any requests or challenges for me, really just go ahead and send them in the comments below. I hope you guys subscribe and stay tuned for more future tutorials. Take care and stay safe.